In this tutorial, I will demonstrate how to compute common measures of dispersion for quantitative variables. Compute measures of dispersion for quantitative data. The data we have before us are the murder rates for each of the states in the South for the year 2009. The murder rates are measured as the number of murders per 100,000 population. To demonstrate measures of dispersion, first of all, I will demonstrate computing the range and interquartile range, and then we'll illustrate how to compute the variance and the standard deviation. For computing the range, the first thing I'd like to do is to reorder our states. I'll first order our states from highest to lowest on this variable. The range is found by subtracting the minimum value from our sample from the maximum value for this variable, or 24.2 minus 4.3 equals a value of 19.9. So our range is 19.9, or we can state it as the interval width that contains all of our sample data is 19.9 murders per 100,000 population wide. Now that the data have been placed in numerical order from highest to lowest value in our sample, the next step would be to identify which is the median case. To do so, we'll use the formula for finding the median case of n plus 1 divided by 2. There are 17 cases in this sample, and 17 plus 1, or 18 divided by 2, indicates that the median case is the 9th case. Whether we count down 9 cases from the top or count up 9 cases from the bottom, we find that Arkansas is our median or middle case, and it has a value of 6.3. Hence our median is 6.3 for the sample. To find the first quartile, or the median of the cases below the median, which in this situation there are 8 cases, we again use the formula for the median case, but this time there are just 8 cases in this lower portion of our data. So 8 plus 1 divided by 2 will give us the 4.5th case. So we count up 4, and we notice that there is no 4.5th case. So we'll find then the average between the 4th and 5th case from the bottom. Adding 5.4 to 4.9 and then dividing that sum by 2 gives us a value of 5.1. So the first quartile has a value of 5.1. We'll perform the same procedure on the upper half of our data to find the third quartile. Counting down from the top to find the 4.5th case, again we notice that there is no actual value, that is the 4.5th case. So we'll have to again find the average between the 4th and 5th cases. Now to compute the interquartile range for this sample of data, we'll subtract the value of the first quartile from the value of the third quartile. So 7.25 minus 5.15 results in a value of 2.1 for the interquartile range. This indicates that the middle 50% of the distribution of southern states in terms of murders per 100,000 population falls within an interval width of 2.1 murders per 100,000 population.